This is section 7.8, sufficient conditions for parallelograms. Okay, so we've been talking about parallelograms in the last section, and we kind of, figured out some different things about them and threw some theorems and stuff with it. This is a pretty short section here. We've just got one theorem and one example. So the only theorem we've got is sufficient conditions for a parallelogram theorem on page 428. So I would definitely write down that theorem, and then I would also have those little pictures there as well, because I think that those are very helpful. I'll put them up here. So basically, with this, you've got 4 different things. So these are kind of similar to the ones we wrote down in the last section. They're not exactly the same. There are some differences, so I would make sure you write it and draw these pictures. So when it's talking about sufficient conditions, that's just like we did with the triangles, where if we were given a list of information like 3 side lengths, remember side, side, side is one of our sufficient conditions for triangles. These are basically your situations for parallelograms that if I gave you that information, every single person's drawings would look exactly the same. Okay? So based on this here, we've got 4 different things. We've got opposite sides being parallel, okay, and then also those lengths of sides being the same there. So basically, if you've got, so it says one pair of sides is both parallel and congruent. So those sides there are parallel, and then that same set of sides is congruent. Then that would be enough information to say, yeah, it's definitely going to be a parallelogram. Next one there, both pairs of opposite sides are congruent. So if you've got your opposite sides there and there, and there matching up to be congruent, then everybody's shape should be a parallelogram, whether they're exactly the same or not, because you could have some differences between your angles there. But everybody should be a parallelogram if you've got opposite sides the same length. Diagonals bisect each other, so if your diagonals are split exactly in half there, basically making that center point there the midpoint, then that's enough information to figure out if it's a parallelogram. And then the last one there, both pairs of opposite angles are congruent, so those angles and those angles match up, then that would also be a parallelogram. So if you have any of those pieces of information, so that, those ones, or those ones separately, that would be enough information to say, yeah, it's a parallelogram. Okay, so we don't have like the 3 letter things with these ones. It's more just, does it fit that? Yes. If it doesn't, then no. But it's kind of similar to the triangles. Okay, so we've only got one example here. So what it says is Bill is cutting a board to be cut on an angle for some wooden benches, and he makes marks of 4 feet on each edge. So on the top here he's 4 feet, bottom there he's 4 feet, and then he's going to cut the boards as shown. And then they want to know, will the opposite angles be congruent? Okay, so the only thing he did here is he just took a board, measured from here to here 4 foot, here to here 4 foot. And then he just ended up taking a straight edge of some kind, connecting between those, and he hacked off that part and hacked off that part. So basically, we want to figure out if this is enough information or not to figure out if this is going to be a parallelogram. Okay, so we've kind of got to think in general here. When you go to a store like Menards or something like that and you buy a 2x4 or buy a board from them, they should end up having parallel sides. So basically your sides here, and then probably here and here should be parallel to each other. Now, in real life, if you actually go to Menards and you buy cheap lumber, it may or may not have opposite sides parallel, but if you buy some nicer lumber, those sides should all match up to be parallel there. So we're just assuming that this is nicer lumber here, and those opposite sides are parallel. And then we've also got here that this is 4 foot, and this is 4 foot. So what they want to know here is we've got to figure out if that's enough information to say, yeah, this is a parallelogram. So we've got a side here, and then the same sides end up being parallel to each other. So that goes with that first part of that sufficient conditions for parallelograms, where you've got your opposite sides and then the same ones that are parallel matching up. So yeah, this is going to be a parallelogram. And then what it asks is, it says, will opposite angles be congruent? Well, if this is a parallelogram, then yeah, our opposite angles here, so like that one and that one, and that one and that one, should match up to be congruent. So you could say yes, and then you could say it's sufficient conditions, conditions for a parallelogram. Parallelogram. Spell that wrong. I think it has an A. Does it have an O or an A? Must be an O. So yeah, it's sufficient condition for a parallelogram. And then if you wanted to, you could say part A of that theorem. So part A of the theorem that we just did. And then, so if it does have that, if this is a parallelogram, then your opposite angles will be congruent. So you could say, then opposite angles will be congruent. Okay, so that is it for those notes. Not a very long section for this one. And this is the last section of this chapter. I know there are a couple more sections in the books, 7-9 and 7-10, I think. But we're not going to do those. We're going to move on to chapter 8 after this. So this is the last section for this chapter.